Okay, this is gonna be a quick video for one-angle pairs. First of all, I didn't feel like working on the computer today. So first of all, we know that there's a word. If we know that we have two angles, and the idea is that we discussed in the last class that an angle is two rays, and we measure the angle based on the degree of rotation of the terminal ray away from the initial rays. First things first, this region inside the angle, it's called the interior. So you might see it in the book. This region is the interior. Sorry, interior. Okay, that's known as the interior. Okay, first definition, adjacent. Two angles are adjacent if they only share a single ray. So the idea is, we can have, let's call this A, B, C, and D. Now we say that ABD, angle ABD, is adjacent to angle DBC because the book says they share no interior points. I like simply the only thing they share is the common ray. So the angles share no interior points. So these are adjacent. Once again, they only share one ray. Okay, the next definition is vertical angles. Now, generally in the class, what I have the students do is I have them draw two lines that intersect like this. So here's our two lines, and then we draw in the angles. And then what the students discover is I have them take their protractor and measure the angle of four angles. And what they discover is that, these two angles, call them 1 and 3, are congruent. And they discover that angles 2 and 4 are also congruent. Maybe all of them are congruent, but in general, these angles. So the question is, what are these pairs? These are known as vertical angles. So how would we define vertical angles? Once again, it's two angles that this is vertical angles. Once again, given two intersecting lines, the two angles that only share, so that's better. Given two intersecting lines, the pairs of angles that only share a vertex, So we can see that angle 1 and angle 3 only share that vertex. 2 and 4 only share that vertex. Hence we call them vertical angles or vertical pairs, and we can also say that vertical angles are congruent. We're going to prove that in the next class. Next, complementary and supplementary. Complementary are two angles whose sum is 90 degrees, and supplementary are two angles whose sum is 180 degrees. And so kids are like, first of all, they don't have to be next to each other. We're going to see with parallel lines that they're two angles, they're adjacent to each other, they're next to each other, but they're consecutive, but they're not necessarily like adjacent. And so, so they don't have to be next to each other. The other thing is, so the question is, how do you remember complementary is 90 and supplementary is 180? Well, I have a little trick. You know what? My little trick goes like this. Change the CO to a 90 and change the supplementary to 180. That's how you remember. Complementary angles are 90, supplementary angles are 180. A linear pair. What is a linear pair? A linear pair are two adjacent angles whose non-adjacent sides are opposite rays. Sorry, this is angles. Sorry about that. Now, what does that look like? What does that look like? Where's my eraser? Well, we have two adjacent angles, so I'm going to take my ruler. I really should be using my ruler. First of all, I know adjacent looks something like this. You know. So here's adjacent angles, but I said these two non-adjacent sides are supposed to be opposite rays. So I'm going to erase this. Right? So this is my first ray. Here's my other ray. And the idea here is this angle 1 and this angle 2, they're adjacent. And because their non-shared rays are opposite rays, we have a linear pair. So angle 1 and angle 2 are a linear pair. Okay. And what can we say about the linear, L-I-N-E-A-R. So angle 1 and angle 2 are a linear pair. What do you think we can say the relationship between angle 1 and angle 2 is? We could say that angle 1 and angle 2 are supplementary. Now they make up a line, and we said in yesterday's class, a line technically is 180 degrees. The last thing we're going to talk about is something called an angle bisector. An angle bisector it's no different than a bisector of a segment. It's something, it's either, we're going to say it's either a line, it can either be a segment, a ray, or a line that intersects an angle such that the two new angles are congruent. What does that look like? Well, I have my angle here. Here's my angle. Here's my angle, and the question is, I need something to bisect it. Well, that could be a line that goes through it. So if this is a line that passes, so let's call this angle A, C, and I'm saying that, let's say that line D, right? So we say that line D bisects angle ABC. Therefore, we would say that angle ABD is congruent to angle CBD. Done. You can do the work in the back of the unit.